All right, so we're back here to this diagram, and as we wrap up elements, compounds, and mixtures and classification of all matter, I want to take the time to kind of tease out some of the nuances of these things as it relates, and how do we actually determine what is an element, what is a compound, what is a mixture. So again, elements only have one type of atom. They cannot be broken down, by physical or chemical means. What that means is that it's as simple as it possibly gets. I don't care if we have a billion gold atoms or 100 gold atoms. If we break it down, it's still gold. And there's no chemical treatment that we can do to further simplify that substance. It is what it actually is. And so those are elements. Now, if we take two or more elements together, we chemically combine to get a compound. And what that means is that we get a totally different unique substance when we combine these two. And so we'll look at an example here in a moment. But they chemically combine. These can be broken down. Chemically. And then we have mixtures which are physically combined. And they can be broken down physically. Let's go investigate this and talk a little more in detail. So what we have here is elemental magnesium. Magnesium in its purest form. So every one of these atoms looks identical. We can't break this down or purify it anymore. So what we're going to do is we're going to start with a little bit of magnesium ribbon in this form here, and we're going to react it with something else. We're going to react it with oxygen out of the atmosphere. Now, oxygen is, you can't see it, you can't really feel it, but it's there, and we'll talk about its properties next. Okay, so let's talk about elemental magnesium. I've got a spool of ribbon here, and you can kind of see that it is somewhat shiny. It's kind of been oxidized a little bit, so it's lost some of its shininess. But if we talk about the properties of magnesium, it's metallic. It's a metal. It's found on the periodic table. I can bend this without it breaking. Obviously, it's in this sheet-like form, so it's malleable. It's also ductile. It conducts electricity. It's reactive with oxygen. So solid, shiny, malleable, ductile. These are its properties of elemental magnesium. Now we're going to react this with oxygen out of the atmosphere, which I'm breathing in right now, and it is gaseous, it's colorless, it's odorless, we can't smell it, we can't see it, so it's flammable, it's needed for combustion. We use oxygen to ignite fires and so forth. So these are the types of things we're comparing: magnesium and then oxygen. We're going to combine the two, chemically combine them to form a compound, magnesium oxide, and this is what it looks like. So we're in the lab room, and we've got a strip of magnesium in our little pliers there, and we're using a burner to ignite it to start this reaction. Here, the magnesium and oxygen are combining together, and it's very, very bright. If it was in person, you wouldn't be able to look at this. All right, so this is the product of this reaction. So we have magnesium over here in the elemental form. This is what we reacted with oxygen. And then this is magnesium oxide after the reaction. Now notice we've got a change in properties. This was shiny and metallic looking. This is white and it's dull. It's not shiny anymore. This was malleable and ductile. This, when you touch it, shatters. This is brittle. This would no longer conduct electricity. It's not malleable or ductile anymore. And so our properties have changed completely. We can see that the magnesium is no longer magnesium element anymore, but it has in fact combined with oxygen. And so we have a compound where magnesium and oxygen are chemically combined to form this compound, and the properties are completely different. So we took two elements, combined them chemically to get a compound. Compounds can be broken down, but they have to be broken down chemically. And so what we do is we reverse this process and we take a compound with a unique set of properties and we break it down into its elements, which have their own unique properties. So in this next demonstration, we're going to go backwards from taking water and we're going to break it down into hydrogen and oxygen through the process of electrolysis. So in this clip, we have a beaker full of water. We're passing electricity through it, and I have two test tubes collecting gas at the top of them. You can see the bubbles rising to the top, and one of these test tubes is going to be collecting hydrogen. That's the one we're looking at right there. Look at the bubbles coming off of that little platinum ribbon there. And then the other one is going to be collecting oxygen. You can see those bubbles on the far right side of the screen. And so we're going to collect hydrogen and oxygen. Both of these are going to be in their gas forms. And we're going to explode some hydrogen when we're done with this demonstration. So we took water, we split it apart, we got hydrogen, we got oxygen, and they're both gases. Hydrogen seems to be extremely flammable. So in this next clip, I'm going to demonstrate the properties of hydrogen being able to react when exposed to heat and be flammable. And so you're going to see a very, very quick ignition in the test tube. Check it out. Ready? Here you see the Hindenburg in 1937 was a giant air carrier that held passengers, but it was filled with these bags of hydrogen gas, and you can see that this was very, very flammable and explosive. This was a big disaster, but this is the Hindenburg, a little piece of history tying in hydrogen and its flammability with our discussion today.
Okay, I'm eating a mixture. This is a cool mixture that was made by Miss Long, and you can see at least a couple of the ingredients. There's popcorn, there's pretzels, somewhere in there there's dark chocolate chips. Ooh. Oh, and I think peanuts too. So all of those different things are here and they're mixed together in this popcorn snack. It doesn't have a different name necessarily, but each of those components keeps its own property. So it's the same properties it had. So this pretzel still has all the properties of pretzels. Just putting it into this mixture doesn't change it any. They are keeping all of their own properties within this mixture. It didn't change them. Unlike when you put things together like the magnesium and the oxygen in the video earlier, those come together, chemically combine, and make a new compound. And it's gonna have new properties that are different from the elements that came together to make it. But this is delicious.
So not only do pretzels and popcorn keep their properties in terms of taste and texture and all of those things, but you know, when we make mixtures, things are going to keep properties such as melting point and boiling point and we will be able to use those to separate mixtures. We talked about that earlier. So like if I have two substances that are mixed together, or maybe they were melted and then resolidified, and I expose them to heat, we're going to observe two different melting points. I put two liquids together, like alcohol and water, and I put them into the same container, mix it up, and then expose them to heat. I'm going to observe two different boiling points. Alcohol is going to boil at a lesser temperature, and then water is going to boil at a higher temperature. And so it's important to understand that even though we might have a homogeneous mixture, the properties of each individual component are going to stay the same. With a compound, however, if we take and we chemically combine substances, two liquids, for example, that's going to change our melting point, our boiling point, our density. All of those things are going to change in a compound. In a mixture, we're going to keep those individual unique properties, even though they come together. Maybe it's homogeneous, maybe it's heterogeneous. But important things to flesh out here, and hopefully this information comes in handy as you answer the questions for today's quiz.